Indices, that is to say powers, are something which will crop up throughout the Maths A level in a variety of kinds of questions, and which early on in the specification you will be prompted to come to terms with, to become familiar with the ins and outs of their rules if you aren't already. So we're referring to something like this, where you could have something to a power, such as we could simply say x cubed, so x times x times x is times by itself that many times, or we could apply it to real numbers, so we could say like 7 squared, so 7 times 7 giving us 49. When it comes to manipulating these though, there's a few different things that we can do. We can first of all combine them. If, say, we just had the same base letter or number and then times together two powers, this would be the same as that base letter or number with the powers then added. So if we had 2 squared times 2 cubed, that would be the same as 2 to the 2 plus 3, which would be 2 to the power of 5. Same if 2 was any other number, same if 2 was any letter. If you were dividing, it would be the opposite, where then there would be minus in the power. Alternatively, if you have that number or letter to a power inside brackets to then another external power, so power bracket power, this is now the same as those two powers times together. So if it had been that 2 squared, but then this was cubed, that would now be 2 to the power of 2 times 3, which would be 2 to the 6. So it's just a distinction to make. If the base number is being times, then you're adding the power. But if it's a power bracket power, then you're timesing the power. If you want to think about it in the bracket sense, as in this case, so 2 squared cubed, so it's going to be 2 squared times 2 squared times 2 squared. This is now just like the first rule. We are now going to add these up, and 2 add 2 add 2 is also 6. But we can also start changing the actual form of this power. We could make it a negative. If you have a negative, this is basically saying there's going to be 1 over that letter or number to that same power. So if it was 2 to the minus 2, that would be 1 over 2 squared. If we had had x to the minus 5, that would be 1 over x to the 5, and vice versa. Some topics may prefer you to put x terms to a specific power rather than being in the denominator. So if you started with a fraction, you can turn it into a power by saying, okay, it's the negative of whatever number that was. Speaking of fractions though, you could have a fraction in your power itself. Let's start off by just considering if it was 1 over something. In that event, it would be the nth root of x. So if it was x to the power of a third, that would be the same as the cube root of x. If we had 4 to the power of a half, that would be the square root of 4, which would be plus or minus 2, because when you square root, you have two possible values, the positive and the negative. The situation of the question may negate one of them, but you should at least consider both initially. If, however, we then have a numerator on that fraction, you can think of it either as the nth root of x to the m, where m was that numerator, or you can do the nth root first and then do it to the power of m afterwards. It doesn't really make a difference. Or indeed, in other words, you can think of it as x to the power of m, and that's then times by 1 over n, and you would apply 1 at a time again in either case. So if we had 8 to the power of 2/3, we can either think of this as the cube root of 8 squared, or cube root of 8 then squared. In either case, so 8 squared is going to be 64, and the cube root of 64 is 4. Or, if you did the cube root of 8 first, that's going to be 2, and 2 squared once again, is 4. They both get you the same answer. It doesn't matter which way you treat it. Okay. If to wrap up this section here then, we were just to combine the last couple of ideas together, we had x to the power of minus m over n. So we not only have a negative power, but a fractional power at the same time. Well, as before, the minus is saying we're going to be 1 over, so it'll be 1 over here, and then underneath will be the x to the m over n. So, for an example, if we had 81 to the power of minus 5/4, that's going to be the same as 1 over 81, and then we could either say it's like the 4th root of 81 to the power of 5, something like that, or the 1 over the 4th root of 81 subsequently to the power of 5. I'm just going to use the latter because it's going to get you a smaller number first. So the 4th root of 81 is 3, so it's saying 1 over 3 to the power of 5, and then that's going to be the same as 1 over 243. If we're clear then on how we're going to use each of these different principles just to rewrite any given expression to a power, let's just see how we can get along with a few examples of our own. So first of all, if we were to try to simplify x squared and then brackets 4x to the power of minus a half, and that in turn in brackets squared. If we were asked to turn 32 times root 2 into the form of 2 to a power here, and we had to identify what the power is. If we were to try to simplify, or expand and simplify, 16x to the 12 to the power of 3/4, and then lastly, to work out what 125x to the power of 9 over 8 to the power of minus a third is going to be. So we're going to want to consider what powers are we going to deal with first, in what order, and then how do we combine them together. If you have numbers and letters both having the same power applied to them, remember usually the power is only on the thing it's directly touching, unless it's in brackets, so there's a power on the outside of brackets. If you have that event, do the number to the power and then the letter to that power as well, just kind of treat them separately. If we can think about how we're going to apply these, pause the video, have a go for yourself, and then press play when you're ready to compare. So in the first case, if we were to deal with the bracket first, so we've still got our x squared here, but now 4 squared is going to be 16. And then here, when you have a power bracket power, that was this instance here, we're going to times them together. So minus a half times 2 is just going to be minus 1. So x to the minus 1. And if you have a term and then it's just a bracket, that's saying that you're timesing the two together. Times what's inside the bracket by what's outside the bracket. So the 16 is still going to remain 16 because that's the only number involved. But here then, if you have x squared times x to the minus 1, that's like we had here. So both x terms and their times together. You're going to add the powers, or rather in this case, 2 add minus 1. That's just like x to the 1. So it'll just be 16x. Next, if we're going to want to combine these into a single form of 2, we'll want to think about, well, what is this as 2 to a power? What's this as 2 to a power? And again, they're times together. So 32 to 2 as a power is going to be 2 to the power of 5. And then that here is being times by 2 to the power of a half, because again, the power of a half is the same as a square root. So then, again, back to this first rule here, where we're going to times 2 of the same base number together. You're going to add the powers, so you end up with 2 to the power of 5.5, or if you prefer, you can write that as an improper fraction of 2 to the power of 11 over 2. That being then what a was. Thirdly, like we had up here, we're going to apply the power to the number first and then do it to the letter. And because we have both a numerator and a denominator, we can consider one at a time. I'm probably going to consider the denominator first, so I'll think of this as the 4th root of 16 and then I'll apply that to a cube afterwards. So the fourth root of 16 is going to be 2, so we end up with 2 cubed, which is going to be 8. Meanwhile here, if we just have a letter and power bracket power, we're just going to times them together. So 12 times 3/4 is going to give us 9. Yeah, so I'll just write that out here in full. That's about 3/4 x to 9. So in total we have 8x to the power of 9. And lastly, we now have this bigger fraction with these bigger terms, and also to a negative fraction. Now, if we deal with the negative first, usually that would be doing 1 over. When you have 1 over a fraction, that's basically just going to flip it upside down. So this will now become 8 over 125 x to the 9, and this is now just to the power of a third. Third is like a cube root, so the cube root of 8 is going to be 2, and here the cube root of 125 is 5, and the cube root of x to the power of 9 is going to be x to the 3, because again you've got power bracket power, a third times 9 is 3. As I say, this use of powers is something that will come up in a lot of different types of questions throughout, not necessarily as a question in and of itself. So we will get a lot more practice with this just as we go through the various other topics. And now, hopefully this has given you a good baseline from which we can begin.